हेलो एवरीवन, वेरी गुड इवनिंग। तो इंस्ट्रूमेंटेशन का पेपर हो गया आज, गेट 2025। कुछ एनालिसिस कर लेते हैं, कितने क्वेश्चंस आए, कौन कौन से टॉपिक से क्वेश्चंस आए, एंड आई एम गोइंग टू डिस्कस सम इंपॉर्टेंट क्वेश्चंस which subjects are common in what electrical, electronics and instrumentation branch. So we have some conceptual questions from analog, right, and from network, from digital and other subjects, guys. So I am going to discuss some important questions from all these topics. So already I have taken one session on what analog. So the straightforward one questions from that session, that is on what differential amplifier, and again one question on what transistor, that is BJT plus what Zener diode, guys. So I think sound quality, picture quality, everything is fine. Everyone please join session now. Yes please, 1 minute. No, so watch this. First of all, number of questions, guys, that is from the different subjects: network, signal, control, analog, EMFT, microprocessor, means from network. Remember, network is important subject for instrumentation, electrical and electronics. So 7 questions from network, then signal 5 questions, then control around 5 questions, analog 5 questions. I'm talking about the questions, not about the marks. It is of what 1 mark question or of what 2 marks question. तो ये मेमोरी बेस्ड पेपर है, तो मेमोरी बेस्ड हमको जो इन्फॉर्मेशन मिली है. देन 1 क्वेश्चन फ्रॉम माइक्रोप्रोसेसर ऑल्सो, देन डिजिटल 3 क्वेश्चंस, मैथ्स अराउंड 6 क्वेश्चन, मशीन 2 क्वेश्चन, मेजरमेंट 6 एंड सेंसर, that is the core topic of instrumentation branch, around 9 questions, 8 to 9 questions from that. So this is the number of questions. तो एक बार जब कंप्लीट पेपर आ जाएगा तो हम कंप्लीट सॉल्यूशन आपको प्रोवाइड करेंगे यहाँ. Then guys, just direct straight forward, because tomorrow we have gate paper for what electrical branch. So one question from analog, I'm going to solve the questions from analog, then from network, then from what digital. So watch this question. Very simple question. Already in my class I have solved this question multiple times. Okay, now watch this. So VB is given, LED is on, it is given in the question, LED is on, VB is what 0.7 volt, beta is very large. If beta is not given, always remember beta is what very large, means very greater than 1, then you can neglect the base current and you have to find the current through the LED, that is I. This is nothing but IC. So very easy question, right? This Zener diode, because here it is a 12 volt, more than sufficient. What is the current here? 0. This 12 volt is sufficient so that this Zener diode will be in breakdown region. Once the Zener diode is in breakdown region, what is the drop here? That is the 0.7 volt VB. Then remember, what is the voltage at this point? 4.7 volt. Then you can find the current through this RE. Current through this RE. So IC, so what we have to find? The current through the LED. Right? Current through the LED. I. This is nothing but IC, and IC is nearly equal to what? IE, because we are going to neglect the base current. IB is nearly equal to 0. Then finally, what is the IE? 4.7 minus 0.7 upon RE. So this is nothing but 4 upon RE. Okay, if the RE is given as 0.1 kilo ohm, then it will become 40 milliampere. Or according to memory based, some students are saying that it is 1 kilo ohm. Okay, no problem, then 4 milliampere. That is the answer for this question. So this is the I. I is nothing but IC, right? And so on. So that is the answer for this particular question, guys. Very simple. I think it is of 1 mark or 2 mark question. So this is of 1 mark. So please watch that. So आप pattern देख लो. Don't worry about the paper. We are getting very simple questions from what analog and other subjects. So yes, so electrical branch ready for all the conditions. Now second question from what differential amplifier. Differential amplifier, in my class already I have given you the idea about the differential amplifier. If suppose it is question is what, find the V0 by Vs or Vs by Vin. So, memory based, some students are saying V0 by Vs, or some are saying that Vs by Vin. So first, if it is a differential amplifier, if it is a differential amplifier, so already I have given you the two methods how to solve this question. Watch this. First of all, according to virtual short concept, voltage at this point, that is the Vp, and voltage at this point, that is the Vn. Negative terminal voltage, positive terminal voltage. Because it is the ideal op-amp, it is equal. These voltages are equal. So you can find the Vp. First method. What is the Vp? R4 upon R3 plus R4 into Vs. Same voltage is connected here, same voltage is connected here. Vs. Now once you have the Vn, you can apply the KCL. What is the current enter into the operational amplifier? 0. Then you can write Vp and Vn are equal. This is the Vn. Then you can write the Vn minus Vs by R1. Vn minus Vs by R1. Vn minus Vs by R1 plus Vn minus V0. Vn minus V0 by R2 is equal to what? 0. Now you can find the V0 in terms of what? Vs. V0 in terms of what? Vs, and you can replace the Vn by what? Vs. Okay. Now put here, first of all, you can take the LCM and it will become what? R1 and R2. Then it will become R2 Vn minus R2 Vs. Then I will give you the shortcut. Plus R1 Vn minus R1 V0 is equal to what? 0. I have taken the R1 R2 as LCM. Now this will become R1 plus R2 into Vn, right, minus R2 into Vs is equal to V0 R1, right. We have to find the V0 by Vs. So put here this one, R4 upon R3 plus R4 into Vs minus R2 Vs is equal to V0 R1. Now you can take the Vs as a common and then V0 by Vs, and then you can multiply, and then finally you can what? Solve it, right? Okay. So next step, then Vs is common, then you can find V0 R1 by Vs. First of all, remember, just I am taking the R3 plus R4 as a LCM. Then it will become R1 R4. This is the R1 R4, R2 R4. Then minus R2 R3 minus R2 R4. This is the R2 R4, it is multiplied, and already we have taken the Vs common. So this term is cancelled out, and then finally you will get V0 by Vs is equal to V0 by Vs is equal to R1 R4 minus R2 R3 upon R3 plus R4. R3 plus R4. So you can check my calculation also. क्या अब एक चीज, एक प्रॉब्लम है, पता क्या है यहाँ पर? क्या प्रॉब्लम है? ये जो R1 है इसको भी आपको डिवाइड करना है यहाँ. अगर यहाँ से मैं मिस्टेक करता तो मैंने तुरंत चेक कर लिया, क्या इट इज डायमेंशनली इट इज नॉट करेक्ट. Dimensionally it is not correct, right? So very good evening. No, that is the just instrumentation branch. We have some questions from instrumentation paper, because tomorrow we have paper for what? Electrical branch. That's why. So these are the questions. Okay, so just divide it and you will get this answer: R1 R4 minus R2 R3 upon R1 R3 plus R4. That is the answer. You can check. So what is the method here? Find the Vp, equate the Vp and Vn, then write down the KCL at this point: Vn minus Vs by R1, Vn minus V0 by R2, then arrange it and finally get the answer. We are getting this answer, right? Now second method here, already I have given you the superposition. What was the superposition theorem? According to superposition theorem, I can directly write 1 plus R4 by R3. 1 plus R4 by, or directly already I have given 1 plus Rf by R1, that is the R2 by R1, into Vp, voltage at this point. What is the voltage at this point? R4 upon R3 plus R4. R4 upon R3 plus R4 into what? Vs minus R2 by R1 into Vs. So in my session already I have given you the direct formula. So what is the V0 by Vs? Directly you can say V0 by Vs. So you can take LCM R1 R3 plus R4. Okay, then it will become R1 plus R2 multiplied with the R4 minus R2 R3 plus R4. Okay, then R1 R4 plus R2 R4 minus R2 R3 minus R2 R4 upon R1 R3 plus R4. Right? Now again R2 R4 R2 R4 cancel, and guys now we are getting R1 R4 minus R2 R3 upon R1 R3 plus R4. We are getting the same answer, yes or no? R1 R4, no, R1 R4 minus R2 R3 upon R1 R3 plus R4. So guys, with the no need to apply the virtual short concept and so on, because it is a standard circuit, differential amplifier. Already I have given you the idea about the superposition theorem. So directly you can solve this question. Okay, so there are two methods. Method 2, that's the method 1. Okay, virtual short concept you can apply. Now next one, please watch it carefully. अगर इसमें पूछा है what is the input resistance, suppose that is the question, find the input resistance seen by what? Find the input resistance seen by operational amplifier. What is the input resistance? Input resistance means value of the battery divided by the current given by that battery. Value of the battery divided by the current given by that battery, guys. Okay, 1 minute. Yes. Now, if that is the question, find the Vs upon I in. So Vs upon I in means this is the Vs upon I in. So let this current is what? I1. To the positive terminal, let this current is I2. So what is the total current? I in will become I1 plus I2. I1 plus I2. Now you can find. Now you can find here. So what is the I1? Simple. I1 is equal to Vs upon R3 plus R4. What is the current enter into the op-amp? 0. So Vs upon R3 plus R4. Then what is the I2? According to virtual short concept, voltage at this point and voltage at this point are equal. What is the Vp is equal to Vn is equal to R4 upon R3 plus R4 into what? Vs. Now you can write what is the I2 is equal to? I2 is equal to Vs minus Vp or Vn upon R1. Right? Vs minus Vn upon R1. And what is the Vn? This is the value. Now you can find the I1 plus I2. What is the I1 plus I2? You can write here Vs upon R3 plus R4 plus Vs minus what is the Vn upon R3 plus R4 into Vs upon R. Right? Now you can take the Vs as a common. So you, and this is nothing but I. So you first of all find the I upon Vs, then you can find the reciprocal of that. This is the I in. Then Vs is common. Inside the bracket you will get 1 upon R3 plus R4 plus this is the R3 plus R4 minus R4 upon R1 R3 plus R4. Okay. Now you can arrange. बताना भाई क्या ऐसा आंसर दिया था. एक और भी मेथड है जिससे क्वेश्चन एक बार और भी गेट में इससे भी पहले आया था. आई एम गोइंग टू एक्सप्लेन यू. देन I upon Vs is equal to R1 R3 plus R4. Okay, and now you will get here R1 plus this R4 cancel out, then you will get only R3 here. Okay, so what is the reciprocal of that? Vs upon I is equal to R1 R3 plus R4 upon R1 plus R3. Check. We are getting this answer, yes or no everyone? जरा एक बार चेक करो ये आंसर आया है. तो देखो और क्वेश्चन का डेटा भी आप वापस चेक कर लेना क्या ये आंसर आया है या नहीं आया है. R1 into R3 plus R4 and then R1 upon R1 plus R3. Yes. तो ये देखो ये दिस इज द क्वेश्चन, फाइंड द इनपुट रेजिस्टेंस. तो सम स्टूडेंट्स बोल रहे थे सर एमएसक्यू में ऐसा आंसर नहीं आया है. तो मैं एक और हिंट करता हूं आपको. ये तो हो गया एग्जैक्ट मेथड कैसे निकालना है, बट देयर वाज वन क्वेश्चन इन व्हाट गेट एग्जामिनेशन प्रीवियस ईयर क्वेश्चन. What was the question? Just I want to give you the hint, right? Watch this question. This is given here. This is the V2 and this is the V1. What is the input resistance seen by the V1 and V2? That was the question. So input resistance seen by the V1, when we are considering the V1, just we are considering that the V2 is 0. What is the input resistance seen by the V1? The input resistance seen by the V1 is nothing but R3 plus R4. R in 1 is equal to V1 upon I1. That is nothing but R3 plus R4. This resistor, only this resistor. And what is the input resistance seen by the V2 here? So then we are making the V1 is equal to 0. Let V1 is equal to 0. When we are making the V1 is equal to 0, then this voltage will become 0. R4 upon R3 plus R4 into V1, that voltage will become 0. So what is the worst condition? What is the resistance seen by the R1 here? Now this is the R2, this is the V2. What is the resistance seen by that? R1, because this is 0, that is 0. So what is the input resistance seen by this? V2 upon current given by that. That is nothing but R1. Only R1. So if that will be the case, so what is the total current given by, if we are connecting both the terminal, so what is the current given by this? First of all, current here, it is given what? I1, and then second current is given is what? I2. Then, so what is the total current given? According to this, I1 plus I2. Just I am assuming that both the voltages are same, that is Vs. So what is the total current is given? I1 plus I2. So what is the I1? Vs upon R3 plus R4. Vs upon R3 plus R4 plus, what is the current given here? If it is also Vs. Vs upon R1. Now, you can take Vs as a common and here it will become R1 plus R3 plus R4 upon R1 R3 plus R4. Now find the reciprocal of this. Find the reciprocal of this, or you have to find the Vs upon I. So Vs upon I, in that case it will become R1 into R3 plus R4 upon R1 plus R3 plus R4. But guys, remember what I am doing, just I am taking the Vs, what separate thing. Once the Vs is connected to non-inverting terminal, then Vs is connected to what? Inverting terminal. That is one approach according to the MCQ. If it is the MCQ and according to the answer, but that is the right approach. Virtual short concept, voltage at this point and voltage at this point will remain same, and then you can find the answer, guys. Okay, so already I have solved this. What is the input resistance? Now next question on operational amplifier. If you have any doubts, then you can ask. Okay, yes, this type of question, this is the question in instrumentation branch, Kamini. Okay, Now what is the question here? Again similar, find the input resistance. Number of questions on input resistance. Find the input resistance, right? Ye A to D, D to A converter, you have learned about that, right? This is the digital to analog converter. We are having the R, 2R, 4R, right? This is the R, this is the 2R, this is 4R, R, right? And this is the binary, and it is converted into what? Analog. So what is given? B2, B1, B0 is equal to what? 110. 110. Find the R in. What is the resistance seen by the input resistance when this is the B2, B1 and B0 is 110. So just we are assuming 1 means switch is closed, switch closed, and 0 means switch open. So means this switch and that switch is closed and this is what? Open. So we have the two currents only. What are the currents here? First of all, there will be current I2, this is I1, and what is the I0? There is no current I0. So I2 plus I1, total current. Always remember what is the input resistance? Value of the battery divided by the current given by that battery. So what is the current given by that battery? I2 plus I1, because these two are closed. And according to virtual short concept, that is 0, this is 0. So what is the current given? You can say V in upon, this is the V in minus 0 upon what? 3 kilo ohm plus V in upon 6 kilo ohm. This is the V in upon 6 kilo ohm. So you can now find 6 as a LCM. This will become what? 2 plus 1 V in, and finally V in by 2. So what is the V in by I in? 2 kilo ohm. 2 kilo ohm. Or directly you can find, this is the parallel connection, that is 3 and 6 are in parallel. 6 parallel with 2 is what? 2 kilo ohm. Directly you can also find, because this is the voltage connected here, that is the ground here. 6 and 3 are in parallel, directly 2 kilo ohm. If it is asked what is the current given by the battery, if the value of the battery is given 6 volt, then you can find also the current given by the battery. What is the current given by the battery? 6 divided by equivalent resistance 3 milliampere. If the value of the battery is given. Memory based, this type of questions, okay. So if you are enjoying the session, guys, simply subscribe the channel. So because tomorrow we have the analysis of what? Electrical branch. Electrical का paper होगा 5:30. We will start our analysis. We will solve questions from various subject, guys. Okay. तो ऐसे अभी आप तैयार हो जाए, ऐसा क्वेश्चन आएगा तो डोंट वरी अबाउट दैट. सिंपल है. डिफरेंशियल एम्पलीफायर, ये आपका D2A कन्वर्टर पर क्वेश्चन बना हुआ था. देन अब आते हैं जरा नेटवर्क. If you have any questions, then you can send me on Telegram channel. Now, network, first question on what? Dot convention, mutual inductance. So mutual inductance, that is given, and one T network is given, equivalent T network. You have to give the value of L1, L2 and L3 in terms of what? This is given LA, this is LB, and this is the mutual inductance M, guys. Okay. Now, how we can solve this question? First of all, watch. Current enter into the dot. Here current leave the dot. So in opposite direction. Now you can draw the equivalent circuit here. First of all, draw the equivalent circuit. Then directly we have shortcut. लेकिन पहले draw करो equivalent circuit. ये कितना है भाई? 3 Henry. Then you can say J omega 3. This is ohm. J omega. This is what? 2. This is in ohm. Okay. That is converted into ohm. Now what is this? J omega M. What is the value of the M? 4 Henry into what? I2. Because this current is I2. Here we have J omega M into what? M. What is the M? 4. Into I1. Now what about the polarity? This is the current I1, that is the current what? I2. What about the polarity? If the current enter into the dot, this dot will become positive and opposite end will become negative. This will become positive and that is what? Negative. That is in opposite direction. Here the current is leaving the dot. If the current is leaving the dot, this is the current leaving the dot, then this will become negative and this end will become positive. This is negative, this is positive. Now we have the polarity. Now guys, write down the V1 is equal to j omega 3 into I1 plus minus j omega 4 into what? I2. Here you can write the V2 is equal to minus j omega 4 into I1 plus j omega 2 into what? I2. First of all, right here, this is the V2. Now, what is this? You can compare this with what? Z parameters. What are the Z parameters here? V1 is equal to Z11 I1 plus Z12 I2. And V2 is equal to Z21 I1 plus Z22 I2. Now you can say what is the Z11 is equal to J omega 3. And from this, what is the Z11? J omega L1, right? Remember, this is the J omega L1 and this is the, right? Remember, this is the J omega L3, J omega L2. Now, what is the Z11 is equal to? Now you can compare it. चलिए बनाते हैं जरा इसको. Watch this. From this diagram, Z11 is equal to J omega L1 plus J omega L3. That will become J omega L1 plus L3. Okay. Here from that you will get what is the Z11? J omega 3. To compare it with J omega L1 plus L2 is equal to J omega 3. I can give you the direct formula, but here you will get the L1 plus L2 is equal to what? L1 plus L3, L3, not L2, L3 is equal to 3. First equation. Then second, similarly you can say L2 plus L3. Z22. What is the Z22? That is what? 2. And now, what is the Z12 and Z21? J omega L3. Z12 is equal to Z21 is equal to J omega L3. That is nothing but minus of J omega 4. This is the value. Okay. So Z cancel and now you can write here Z12 is equal to Z21 is equal to what? Sorry. Directly you can write L3 is equal to minus 4. Now tell me, you can find the value of the L1. What is the value of the L1, guys? It will become 3 plus L3. What is this? Minus 3 minus L3. That is 3 minus minus plus, that is the 7. Similarly, from this L2 plus L3. So what is the L2? 2 minus L3. 2 plus 4, that is equal to 6 Henry. Okay, and that is the answer. So what is the standard answer? If you have the idea about the standard answer, directly you can solve this question. Directly you can solve this question. What is the standard answer? This is the minus M, right? And that is what? L1 plus M, LA. This is LA. And this is LB plus M. That is 2 plus 4. This is the 3 plus 4. And this is the minus M. So that is the complete derivation. That is the complete derivation, guys. Okay. So in this way we can solve this question. Now, second question from the network. आपका यही आंसर आया था. दिस इज अ इंपॉर्टेंट क्वेश्चन ऑन ट्रांजिएंट गाइस. दिस इज अ इंपॉर्टेंट क्वेश्चन ऑन ट्रांजिएंट. What is given here? I think this is clear to you everyone. Directly you can apply. If you have the direct idea, yes, within 1 minute you can solve this question. But otherwise, that is the method. Write down the equation, compare it with the standard equation, and then what is the z parameter of that? Za plus zb, zc plus zb, and what minus that is the zb. Okay, तो ये आप यहाँ से compare कर सकते हो. Then दिस इज अ क्वेश्चन फ्रॉम द ट्रांजिएंट. बड़ा ही अच्छा कॉन्सेप्चुअल क्वेश्चन था. मैंने बोला भी था कि आपको इंडक्टर से क्वेश्चन आएगा. तो इंडक्टर पे क्या क्वेश्चन है ये देखो जरा. दैट स्विच इज ओपन एट t इक्वल टू 0. दैट एरो इज गिवन मींस स्विच इज ओपन एट t इक्वल टू 0. फाइंड द IT, दैट इज द करंट थ्रू द 120 ओम रजिस्टर एट t इक्वल टू 2 मिलीसेकंड. तो फर्स्ट ऑफ ऑल यू हैव टू फाइंड द इक्वेशन ऑफ IT फॉर t ग्रेटर देन 0. For t greater than 0 guys. Now remember, directly you can use this equation. IT is equal to I final minus I final minus I initial e raised to power minus t by tau. What is the final value of the current? What is the initial value of the current? Now here we have inductor. Inductor does not allow sudden change of current guys. So inductor does not allow sudden change of current means current through the inductor at 0 negative and current through the inductor at 0 positive is what? Same. So first of all, when the switch is closed, this is the short circuit path. Under steady state, no doubt inductor will act as short circuit, but what will be the current? So just draw the circuit exactly at t equal to 0. Then when the switch is closed, 0 negative, circuit is under steady state. This will act as short circuit. This is the short circuit path. No doubt this inductor will also act as under steady state. This inductor will act as short circuit. But current will follow the least resistance path. So what is the current here? 10 milliampere. So what will be the current here? 0. So what will be the current through the inductor? 0. Why? Because it is purely resistive circuit. So initial current through the inductor is 0. And that's why IL0 negative is equal to IL0 positive is equal to what? 0. Inductor does not allow change of current. Now, second diagram exactly at t equal to 0 plus. So what will be the diagram exactly at t equal to 0 plus? Now watch this. At t equal to 0 plus, this switch is open. This switch is open at t equal to 0 plus. Inductor change of the current. That's why what is the current through the inductor? 0. It will act as open circuit initially. Right? Now, then this is the 10 milliampere. So what will be the current? What is the initial value of the 120 ohm resistor? Same 10 milliampere. Same 10 milliampere will flow through the 120 ohm resistor. So I, that is the current through the 120 ohm, I0 plus is equal to what? 120 ohm. I0 plus is what? 10 milliampere. 10 milliampere. That is the current. Okay. 10 milliampere will flow through the 120 ohm resistor. So you can say, sir, that here the current was 0 because the complete current will pass through this. So current through the inductor is 0, current through the resistor is 0. This is the diagram at 0 negative. Now I am talking about the diagram at 0 positive. We are finding the initial current through the 120 ohm resistor. Remember, resistor will allow the sudden change of current, but inductor will not allow. And that's why initially it will act as open circuit. What is the current through the inductor? 0. What is the current through the inductor? It is 0. But what is the current through the 120 ohm resistor? 10 milliampere. Now, we have this equation. What is the current? Initial current 10 milliampere. Now what is the final current at t equal to infinite through the 120 ohm resistor? Just to find the final current, remember at t equal to infinite, inductor will act as short circuit. Again at t equal to infinity, switch will remain open. Inductor will act as short circuit, and this is the 10 milliampere current. And remember, if the resistor is connected in series with the 10 ohm, no need to consider the resistors here. So there is a current division rule. So exactly at I equal to infinite or t equal to infinite, I will become according to current division rule 10 120 divided by 40 plus 40 80. If you want to find current here, then it should be multiplied with the 80. Okay, then it will become 10 into 80 divided by 200. Right? This is the 80 by 20, that is the 4 milliampere. What is the current here? 4 milliampere, and that is the final current. Now you have the initial current, you have the final current, and what is the time constant? So time constant, okay, just to find the time constant, watch this diagram. If you want to find the time constant, always find for time constant for t greater than what? 0. And what is the time constant? L by RTH. Now, for t greater than 0, this switch is open. Second thing, if it is a current source, it will act as open circuit. Remove the inductor, that is the 0.2H. What is the Thevenin's resistance seen from this point? So because these two are floating resistor, so 40, 120 and 40 are in series. So what is the RTH? 120 plus 80, 200. Now you can find the tau. What is the value of the L? 0.2. What is the value? 200. And this will become 20 divided by 2000. This is the time constant, means 1 by 1000 second. And we can say 1 millisecond. Time constant is 1 millisecond. That is the question. Now we have the time constant, we have the initial value, we have the final value. So this is the how we can find the time. These two are the floating resistor, no need to consider. Current source will act as open circuit. Okay. So this is the 1 millisecond is the time constant. Then finally, what is the equation here? What is the initial value? Final value 4 milliampere. 4 milliampere. What was the initial value? 10 milliampere. E raised to power minus t by tau. Remember, it is in millisecond. Then it is the 4 plus 6 e raised to power minus t by tau. That is in millisecond. Now that is the equation. We have to find the current at 2 milliseconds. So you can directly put the 2 here because 1 is what? Millisecond, milli cancel. 4 plus 6 e raised to power minus 2. And if you have the value e raised to power minus 2, then no need to use the calculator. Otherwise, you have to use your virtual calculator. If you have the calculator, then tell me what is the e raised to power minus 2. .135. Now remember this value, 0.135 into 6 plus 4. 4.812. 4.812 milliampere. That is the answer, guys. 4.812. This is the current through the 120 ohm resistor. Normally we are calculating the current through the inductor, but this time we have to calculate the current through the resistor. That is a good question on transient. 4.812 milliampere. Suppose we have to draw the graph here. If you have to draw the graph, what will be the graph here? For example, in same question, now this is not asked in question, just what was the initial current? 10 milliampere. So this is the 10. What is the final current? 4 milliampere. That this is the 4. Now this is exponentially decreasing function. Like and this is the what IT. Okay, this is the one time constant, and this is in two time constant. Here we are getting the 4.81 to here, and this is the 10, and this is what 4 milliampere. That is the graph for IT, current through the 120 ohm resistor. Okay, तो ये आ सकता है. Now next one, if there is any doubt, then yes, you can ask. I will upload the PDF on my app. You can download the app now. That link is given in description, guys. I will upload the PDF just after the session. I will upload the PDF. You can go through it. Then next question is, it is again question from network. Active power given by the source. What is the active power given by the source? Right. We have active power, reactive power, apparent power. Active power is required. So as you know, what is the active power? If you want directly, you want to find the active power, means it will become VRMS, or effective value IRMS. RMS value of this current given by this into what? Cos theta. Where this is called what? Power factor. Theta is the phase difference between voltage and current. What is the voltage active power? Okay, 100 angle degree, that is given. Angle is given, and impedance is given. So first of all, we have to find the equivalent impedance. Then we can use this formula, or there is another formula, guys. What is the complex power? P plus JQ. Right? What is the complex power? P plus JQ. So this is the S is equal to what? I RMS square into what? Z. I RMS square into Z. Directly you can find that P represent what? Active power or active power, and Q represent reactive power. So yeah, from this again we can find. So now first of all, you have to find what? Z equivalent. So guys, Z equivalent, this is the J5, this is 5 minus J5, 10, 10. So you can take what? Common. What is the common? 5 you can take common. Let's remember 5, just to find the Z equivalent, just I am taking the common what? 5. Remember this 5. Now what is the Z? Overall Z will become, this will become 2 because I have taken the 5. This will become minus J2. 2 minus J2, these two are in series. Just I have taken the 5. Now plus these two are in parallel. Just I have taken the 5 as a common. 1 minus J parallel with what? J, means 1, J1. Okay, and remember that 5. So ultimately this resistor will be multiplied with the 5. So overall Z equivalent will become 5 times of Z. First of all, find the Z here. Then it will become 2 minus J2. Then plus, it is multiplied 1 minus J1 multiplied with this one upon what? Plus J1. This is the parallel. So this is cancel out. And then it will become this is minus minus plus 1. J square minus minus plus 1. Then what is the Z is equal to 3 minus. Okay. Now what is the Z equivalent? It is multiplied with the 5. 15 minus J5. This is the Z equivalent. So quickly you can solve. Quickly you can solve this by using this method. Okay. 15 minus J5. That is the Z equivalent. Now what is the magnitude of Z, so that you can find the current? So that you can find the current. This is the, if nothing is mentioned, always remember this is the RMS value. If nothing is mentioned, by default it is the RMS value. What is the Z equivalent? What is the magnitude of Z? That is equal to, I am not going to find the power factor and so on. So that is 15 square plus 5 square root over 250. 250 ohm, root over 250. Find root here, 250. Now Now you have this value. Up to this point you have the Z equivalent. Then what is the current given by this battery? Just find the magnitude. Okay, 100 upon what? 250. Then use this formula to find a complex power here. P plus J2. What is the IRMS square? 100 by root 250 square into Z equivalent. What is Z equivalent? Minus J5. We have to find the P. So just simply it will become 100 into 100 upon 250 into what? 15. Minus, this is the J5 into 100 square upon 250. Guys, this is the P and this is called what? Effective power or active power. What is the active power here? Everyone calculate. 100 into 100 into 15 divided by what? 250. 600 watt. 600 watt. So no need to find the power factor. Again, that is the second method. Yes, you can also find the power factor. You can find the angle here. That is the Z equivalent. You can also find the angle of that. 5 upon 15. Then 18.434. Minus. Okay, this is the angle of the jet impedance. It is means it is capacitive. It is capacitive means what is it? Leading circuit. So current will lead the voltage by what? This value. Current will lead the voltage by this value. Then what is the power factor will become? 18.4, cos of 18.434. This is the power factor. 0.948. 0.948 will become power factor to what is the RMS value? 100. What is the RMS value of I? Already we have calculated RMS value of the I. That is the 100 by root 50, 250. Okay, into value 0.948. Now find. Please check my calculation. We are getting the same answer. Where is the IRMS? This is the value. Yes, please. VRMS, that is given 100. Now, 1 minute. Yes, that is correct. Now that is the value. Okay, so I have find multiplied with the value of the VRMS and then finally guys multiply with the cos theta and you will get the answer, that is the 600 watt. So this is the two method. Check your calculation also and that is the value guys. Okay, so in this way you can solve, but directly no need to find the power factor and then what multiply and then find the VRMS, IRMS reactive. That is one method. And what is given in the question? Power, active power given by the source. That is the active power given by the source. तो थोड़ा सा लेंदी होता है, थोड़ा ट्रिक यूज करोगे तो डायरेक्टली यू कैन फाइंड. कॉम्प्लेक्स में थोड़ा सा लेंदी हो जाता है, इलेक्ट्रिकल में भी क्वेश्चन आते हैं, ऐसा सेम क्वेश्चन इलेक्ट्रॉनिक्स में भी आ सकता है. देन अब आते हैं जरा नेक्स्ट उस पर. अगला क्वेश्चन है, बताइए जरा अगला क्वेश्चन क्या आ रहा है. यस प्लीज. बोलिए जरा. Yes, this is nearly equal to 600. देख लिया आपने, दोनों इक्वेशन को कैलकुलेट कर लीजिएगा, पावर यहां से भी आ रहा है, वहां से भी आ रहा है. नाउ दिस इज द क्वेश्चन गाइस. Similar question we have two this type of two questions here in network. This is a very important one. Watch this. This is the 3 kilo ohm, 6 kilo ohm, 6 kilo ohm, 3 kilo ohm. Now these two are equivalent diagram guys. This is given in the question. These two are equivalent diagram. Okay, you have to find the VC, find the value of the R1, find the value of the R2, right? Similar type of questions again. I will solve another question on same diagram. Now this is the 18 volt battery is given 3 kilo ohm, 6 kilo ohm, 6 kilo ohm, 3 kilo ohm. Then simply watch this diagram. First of all, you can redraw it. This is the 3 kilo ohm, 6 kilo ohm. This is the 18 volt battery. So you can disconnect this 18 volt battery here. Here the 18 volt battery is connected. Here the 18 volt battery is connected. Now, what is the value of the V1? The value of the V1 will become three, 6, 18. Then according to voltage division rule, upon 3 plus 6 into what 18, that is 9, 18 divided by 9, that is the 2 into 6, 12 volt. We can say this is the VTH1. And what is the RTH1? These two resistors are in parallel, 6 parallel with 3, that is nothing but 2 kilo ohm. Okay. Similarly, here you can apply the Thevenin's equivalent. This is 18 volt, this is V2, this is 6, this is 3. So what is the V2 is equal to 3 divided by 6 plus 3 into 18, then it will become 6 volt. Now what is the RTH2? Again R1 parallel with, this is the 6 parallel with the 3, 2 kilo, right? Again 2 kilo. Now what is the value here? 12 volt guys. Suppose I am moving from this point to this point. What is the resistance seen by that? 2 kilo ohm. What is the resistance seen by the V2? 2 kilo ohm, Thevenin's. What is the voltage seen by this? 12 volt. But it is the 3 volt. 3 plus VC. 3 plus VC is equal to 12 volt. So what is the VC is equal to 9. So this is the 9 volt. Now, when I am putting the 9 volt here, so 9 minus 3, what is the resistance seen by that R2, V2? It is a 6 volt. 9 minus 3, it is a 6 volt. And this is the 9 plus 3, it is a 12 volt. So, these two diagrams are equivalent if the value of the VC is 9 volt, value of the R1 is 2 kilo ohm and value of the R2 is what? 2 kilo ohm. That is the question guys. Okay. अब आता है, देखो एक और क्वेश्चन दिया जिसपे थोड़ा सा ना ध्यान रखना. ये बहुत बार नेटवर्क एनालॉग में हम लोग कई बार इसको लगा चुके हैं, सेम लॉजिक. ठीक है, एक और क्वेश्चन बनाते हैं, उसके बाद ये एडमिटेंस पर भी क्वेश्चन बनाएंगे. सिमिलर क्वेश्चन. This is from the measurement guys actually. This is given as 1000 ohm. This is given as 1000 ohm. And this is 1010 ohm. It is unbalanced. Now here one galvanometer is connected. Its internal resistance is 100 ohm is given. You have to find the current through this. Find the value of the Ig, and I think this is given as 4 volt. This is given as 4 volt. You have to find the Ig here. Okay, so unbalanced bridge 1010. So same logic. First of all, break this. You have to find the I here. I think it is a 2-mark question, guys. So what is the, first of all, apply the Thevenin's here. Cut from this point and apply the Thevenin's here. This is the A point and that is the ground. First of all, apply the Thevenin's here. So Thevenin's means this is the 1010, this is the 1000. 4-volt battery is connected. So what is the VTH1? 1010 upon 2010 into 4. What is the RTH1? 1010 parallel with what? 1000. Parallel with 1000, guys. This is the RTH1. Now, second, here 1000, this is the 4 volt. So what is the VTH2 here? VTH2 will become 1000 divided by 2000 into 4. So this is simple 2 volt. And what is the RTH2 will become 1000 parallel with 1000. That will become what? 500 ohm. Very simple. 1000 parallel with 1000. Now you can replace this circuit by its Thevenin's equivalent. Then this is 2 volt, 500 ohm, right? And this one, watch this. What is this? This is the value 1010 upon 2010 into 2 volt. This is the 4 volt. And now this is nearly equal to what? 500 ohm. 1010 parallel with 1000. It is nearly equal to what? 500 ohm. You can put the value nearly equal to 500 ohm. Otherwise, you can find the value, exact value. Or now this resistor is connected. What is the value here? 100 ohm. What is the value here? 100 ohm. You can also find the value 1010 parallel with 1000. You will get 502.48. If you want to calculate the exact value, then it will become 502.48. This is the 1010 parallel with 1000. Now find the value here. $2.0099. ठीक है, फ्रैक्शन में निकालना पड़ेगा, otherwise you will get the wrong answer. And finally you can find the current IG here. This is the current through this. So IG will become, this is cancel out, and then you will get 404 upon 201 minus 2 divided by total resistance. Now you can find the exact value here. Okay. The numerator will get 2 upon so I think 1.841 milliampere. The answer is, this is in ampere because it is in ohm, or you can give the answer 1.814 milliampere. Check my calculation, otherwise that is the right answer. What is your answer? Give me the answer in comments box. This is the important question. Okay, so this is the 4,000, 1,000 and 1,010. You can solve this similar type of question. Now there was the one question on what admittance, guys. Admittance, that is the question. Y is given, YB is given, YC is given. These are connected in parallel and one battery is connected here. Then IS is given, IA plus IB plus IC, or I is given IB plus IC, or I think that diagram is also given, but this is a memory based. So suppose it is a diagram, let this battery is connected here, one inductor, one resistor, one capacitor. This is the RLC circuit in parallel. One impedance is given as YA minus J 0.2 Siemens, YB 0.3 Siemens, and J 0.4. Now this current is IS and this current is what? Let it is I dash. This is IA, this is IB, and this is what IC. And this value is given as V. What is the V here? 25 root 2 angle 45. Then you have to find the angle between what I and IS, and you have to say what are the I lead the IS or I lags behind the IS. By what angle? That is the question. Very simple solution here. First of all, what is asked? What is the difference? Whether I lead the IS or I lags behind the IS, by what angle? That is the question. Now, first, about the voltage in a parallel, the voltage will remain same. Parallel, the voltage will remain same. So, what is the overall admittance? Then remember, current will become V by Z, or you can say YV. Y is the admittance. So in first case, what is the overall admittance? Suppose I am going to find the IS. V by Z, what is the, or YV, what is the Y? Add these three. YA plus YB plus YC. Simply add this. So when I am going to add this, it will become plus 0.3 J 0.4 into V, and therefore IS will become 0.3 plus J 0.2 into what? V. Okay. Now you can find the angle of this with respect to it, that is the 45. Then okay. Similarly, what is the IB or I dash? I dash is the current through this branch and that branch, or this is the V is connected in parallel. So what is the overall admittance up to this point? So up to this point you can say Y dash into V. This is the 0.3 plus J 0.4 into what? V. Okay. Now V is common here. V is the common here. So just find the angle of this. Angle of this and angle of this. No need to find the magnitude. Simply we have to say whether it is leading or lagging. So leading or lagging. So what is the angle of 0.3 and 0.2? That is the 10 inverse of 0.2 by 3. So 0.2 divided by 0.3, that is the 2 by 3. Shift 10 inverse of this. You will get 33.69. 33.69. So no need to find the Y. What is the angle? 33.69 and V. Then similarly, here 0.4 divided by 0.3, that is 4 by 3, 53.13. So it will become magnitude of Y dash, angle will become 53.13 into what? V. What is the angle of V? 45. No need to add, just simply subtract it. 53.13 minus 33.69. 19.44 means IB plus IC or this I dash will lead the IS by what? 19.44. Check my calculation. This I dash, that is IB plus IC, leads IS by 19.44. Okay, and that is the answer. So admittance directly you can calculate. No need to calculate, no need to find the complete current, or no need to find the complete, and so on. Okay, so that is the question on admittance. Now one or two questions from what? Digital, guys. So this is the question from the network. तो देख लो जरा कल कितने क्वेश्चन आ जाए इलेक्ट्रिकल में. कूल रहिएगा. अगर अभी भी जाग रहे हैं तो कोई बात नहीं, अगर आफ्टरनून सेशन है आप अपनी नींद पूरी कर लीजिएगा भाई. अब आते थोड़ा सा एक दो क्वेश्चन है डिजिटल पर, वो भी देख लेते हैं. ये देखो जरा, क्वेश्चन ऑन मल्टीप्लेक्सर, 1 4 cross 1 mux is given, very easy question. 2 cross 1 mux is given. Two selection line P and Q. This is S1, S0, 0 1 1 0 it is given. The third selection line is this one. This is the 2 cross 1 mux, and output of this is connected here. Now what is the output at this point? Simple question. What is the output at this point, guys? Remember, it is nothing but XOR gate. It is nothing but XOR gate, guys. PQ 0 0 0 1 1 0 1 1. 0 0 means it will select I naught. What will be the output? 0 0 1 you will get 1, 1 0 you will get 1, 1 1 you will get 0, means it is a nothing but XOR gate. Up to this point it is a XOR gate. So here you will get P exclusive OR with Q. P exclusive OR with Q. Then what is the Z here? When this is R bar, it will select 0. What is 0? This is the P exclusive OR with Q plus R. When it is 1, it will select 1. Okay. Now apply the distribution law. It will become R plus R dash into R plus P exclusive OR with Q. This will become R plus R dash will become 1, and that is the, what is the answer? Z is equal to R plus P exclusive OR with Q. So this was the MSQ. The right answer for this question is R plus P exclusive OR with Q, guys, and that is the correct answer. So there are 4 options. R multiplied with the P exclusive OR with Q, R plus P plus Q, R exclusive OR with the Q exclusive OR with what? P, and so on. So that is the correct answer. So that is a simple question on what? Multiplexer. ये भी आया देखो instrumentation branch में. Then next one is, if you have any doubt, then yes, you can ask, guys. The next question is from the digital. Very simple question again. X is equal to A bar B bar plus A bar C bar. Then find X bar. Or there are different options. A bar plus B bar plus C. This is a very easy question, guys. A bar plus B plus C, B plus AC, A plus BC. Very simple question. Okay. Then simply this is X. So you can write X A bar as a common. It will become B bar plus C bar. Now apply the De Morgan's theorem. The whole bar. This will become what? A cancel plus that is the answer D. De Morgan's theorem apply and you will find the answer. Okay, very simple one. A plus BC. There are multiple ways to solve. You can apply. Okay. Last 2 path admittance is okay. Yes. We can also find directly by what? Current division rule. In admittance, na? In admittance, we can also find by the current division rule. Okay. Yes. Total current and divided by that. Okay. So ये है second method. Again, you will get the angle here. Right. This will be your answer, or your method is also correct. Current division rule means what? This is the total current, and if you want to find the, remember, this is directly proportional to Y, na? So if it is directly proportional to Y, then that is the current. This is total admittance divided, this is the admittance divided by that total. It will give you the value of the current. But in this case, simply you have to find what is the angle between what? I dash and IS. Okay. And that's why directly I have solved what is the angle and so on. Then Next question from the digital, another question on digital. So already we have solved a number of questions, guys. Now watch this. One OR gate is connected here, one AND gate is connected here. This is the D1, this is the Q1, this is the Q1 bar, this is Q0. Here it is a control signal, OR gate. This is the D0. Now this D0 is connected, Q1 bar. Here it is also connected. Synchronous means same clock pulse is given here. The frequency of the clock pulse is 12 megahertz, and this is the control input. This control input has two levels. One is what? 0, one is what? 1, and you have to give the clock frequency, or 1 or 0, right? 1 or 0, and you have to give the frequency of the output. Frequency of the output. Here we are taking the output. Find the frequency of V0. Frequency of output for different cases. If the I is 1 and I is 0. And this is the MSQ, guys. MSQ means what? MCQ, sorry. Answer is given 6 megahertz and 4 megahertz. 4 megahertz, 3 megahertz, like this. You can verify it. Okay, this type of answers. Now, how to solve this type of questions, guys? So, this is a synchronous, we can say it is a synchronous counter. We have given the same clock pulse to both the flip-flop. This is a control signal. Remember, in OR gate, if any one of the input is what? 1, then it is disabled. Disabled means it will mask the input. What will be if any one of the input is 1? Just I am taking the first case, I is equal to 1. First case I am taking the I is equal to what? 1. We have to find the frequency, na? Remember, we have to find the frequency. Just I am taking the I is equal to what? 1. In OR gate, if any one of the input is 1, this is 1, control signal. So it is what? It will become 1. 1 plus something is what? 1. So it is 1. Now here it is the Q1 bar. So this is the Q1 bar. Q1 bar and with the 1 will become what? Q1 bar. So D1 is Q1 bar. And what is the next state for D flip-flop? D1. So here I is 1. You are taking the I is equal to 1. Then this is the Q1. This is the Q1 naught. You have to find the frequency of the Q1. What is the Q1 here? That is the D1. And what is the D1 here? Q1 bar. Remember. What is the Q0? Q0 is equal to D0. And what is the D0? It is also Q1 bar. It is also Q1 bar. Now, Q1 is the equal to Q1 bar. Q0 is also equal to Q1 bar. This is the D1. And this is the D0. Now, if you are going to start with the 0, 0, 0. Initial is what? Q1 and Q0 is 0, 0. So it will become in next clock pulse, it will become 1 because it is a Q1 bar. So it will become 1, it will become 1. After next clock pulse, this is the Q1 bar, it will become 0, it will become 0. Again after next clock pulse, it will become 1, it will become 1. So guys, focus on the Q1. Continuously, we are getting what? 0, 1, 0, 1, 0, 1. Now, this is the time period of the output. And the time period is just double of the time period of the clock frequency. The time period of the clock cycle. So what about if the time period double? What about the frequency? Half. What of the frequency of the output will become FC by 2. 12 by 2. This is what? 6 megahertz. So read question carefully. If the control signal is 1, then the frequency of the output at this point will become half. That is what? 6 megahertz. This is the output, square wave. Perfect square wave we are getting 0, 1, 0, 1. Perfect means duty cycle is exactly 50%. We are getting the square wave. So when we are giving the 1 here, we are getting the 50% duty cycle square wave. That may be the question. That may be the question. What is the duty cycle of the output? So 50%. Perfect square wave. Now, if we are going to change the control signal, just change the control signal. If the control signal will become what? 1 here, 0 here. Then, if the control signal is 0, then Q0 0. Q0 bar, Q0 0 plus Q0 is what? Q0. If it is 1, it will become 1. If it is 0, it will remain 0. 0 plus 0 is 0. 1 plus 0 is what? 1. Q0. Now here it is the Q1 bar. What is the value of D1? D1 will become Q1 bar Q0, AND gate. This is the AND gate. And what is the D0? D0 is Q1 bar. Now, this is the Q1, Q0. Next state, just I am writing the next state here. This is the D1. So what is the D1 here? Q1 bar Q0. What is the D0? Q1 bar. Start with the 0, 0. Okay, start with the 0, 0. So what is the Q1 bar? It will become 1. What is the Q0? 0. So what is the next state? It will become 0. This is 1, this is 0, this is 0. This is the Q1 bar. This is 0, that's why it will become 1. So next is, this is the first. After 1 clock pulse, it will become 0, 1. And now, Q1 bar is what? 1. Q0 is 1, and that's why it will become 1. This is the Q1 bar. This will also become 1. We are getting the 1, 1. Then after that, again this is the Q1 bar. So what is the Q1 bar? It will become 0. This is the Q1, 1. And now Q1 bar, it will become 0. Are you getting my point? This is the next state, guys. So what is the present state? 1. And that's why the Q1 bar will become 0. 0 into something is what? 0. Now here it is the Q1 bar. So Q1 is 1. And that's why what is the Q1 bar? 0. Then repetition. After that repetition. So after that again you will get the 0, 1. Again you will get the 1, 1. After that continuously there is a repetition. After 1, 1 again you will get the 0, 0. So after how many clock pulse there is a repetition? After 3 clock pulse. 1, 2, 3, 1, 2, 3. So after 3 clock pulse there is a repetition. The time period will become what? Time period will increase by 3 times. 3 Tc. So frequency will decrease by the 3 Tc. So what is the frequency of the output? What is the frequency of the output will become Fc by 3. That is the 12 by 3. So it will become 4 megahertz. 4 megahertz, guys. So answer was the option A, guys. In this question, option A. If these are the options, then 6 megahertz and 4 megahertz. So watch the question, read the question carefully. Memory based question, guys. It is a memory based. So it is a 6 megahertz and what? 4 megahertz. You can solve. Now that is a good question. Now in second case, what we are getting actually, we are not getting the symmetrical square wave, guys. We are not getting, in first case we are getting the symmetrical square wave. In second case we are not getting the symmetrical square wave. Which type of square wave we are getting? Asymmetrical square wave. So what is the, I am just asking you, what is the duty cycle of that? So this is the 0, 0, then 1, 0, 0, then 1, 0, 0, then 1. So this is the 0, 0, 1, 0, 0, 1, 0, 0, 1. So if suppose I am going to divide in 3 parts, so this is the total T. So for T by 3, it is the on period, and this is the 2T by 3 is what? Off period. 2T by 3 will become off period. So what is the duty cycle? On upon total. On upon total, so duty cycle will become T by 3 upon T, that is what? 1 by 3. Or you can multiply it with the 100, it is a 33.33%. That will become duty cycle. So that question is not asked, but yes, they can ask what is the duty cycle for this waveform. It is the 001, 001, that is the duty cycle. So what we are doing actually, but just by changing the control signal, we are changing the frequency of the output. Initially the frequency was what? 6 megahertz. Now the frequency is what? 4 megahertz. I think 4 megahertz. Yes, 4 megahertz. Also we are changing what? Duty cycle. Right? Duty cycle is also different. The frequency is different. So question और बन सकता है, that is the MSQ. By simply changing the control signal, only there is a change in the frequency, or only there is a change in the duty cycle, or change in the frequency as well as change in the duty cycle. So both. Then last question, guys, 1 minute. I have one more question. I think one question from what we can say a microprocessor, or we can say what memory, ROM. Okay. So I have taken that a number of classes on microprocessor. So this type of system is given. Here it is the 4K memory is given, 4 kilobyte memory is given. Here it is a 16 kilobyte memory is given. Remember, in a 4 kilobyte, total 12 lines are required. So normally we are writing like this, from A0 to what? A11. How many lines? 12. Because 2 to the power 12 is what? 4096. And we are saying that this is the 4K. 1K is equivalent to what? 1024. 1024. So 4K is 4096. So total 12 lines are required. And what? Enable gate is also connected. One enable gate is also connected. And gate is connected here. Downward or upward, it is the enable gate. How many lines are connected? Because 12 are here connected, to 4 lines are here connected. 4 lines means that is from A15 to what? A12. And then it will become, we can make like this, A12, then it is A11, then A0. So total 16 lines. In 8085, total 16 address lines are there. Then here it is a 16K, means we have to increase the number of address lines. Then we are giving from A0 to A13, because 2 to the power 14 is equal to what? 16K. Remember, 16K means what? 16 into 1024. This much memory. Now here AND gate, right? This type of circuit is given. Memory based question. This is the A15, this is the A14, and it is the active high enable pin. So that is just, we have to find the address range of this. So what is the use of this? Nothing mentioned. Find the address range of new memory. So what is the address range? Just we are writing from A15, A14, A13, A12, then A11, A10, A9, A8, A7, A6, A5, A4, A3, A2, A1, A0. So it is a memory. Actually, it is not microprocessor, it is a memory interfacing. So A15, A14, this chip will be enabled when it is 1, it is 0, so that we are getting 1 here. It is 1, it is 0. So what about the lower order? This is called higher order address, page number, these are called line numbers. What about the higher order? What are about the lower order? Initially all are 0. Higher order address will remain same, page number will remain same. What about the lower order? Lower order will become 1111. Make the group of 4, it is 0, it is 0, it is 0, it is 8. So it will become 80000H. Then here it is the 1011 means 8 plus 2 10 plus 1 11. What is the 11? B. 8 plus 2 10 plus 1 11. 11 is what? Remember B in a hexadecimal. It is F 15. F F B F F F H. And that is the memory range. That is the memory range, guys. So that is the question from what microprocessor. We can say, but it is a find the range of the that memory. So it is also the question from what digital electronics. You can say. So this type of questions, guys. So if you have any more question, then please put on my Telegram channel. Okay, then I can solve some questions from what different subjects. I think already I have covered. Okay, then thank you very much for attending the session, guys. Remember, if you have more questions, then yes, you can ask on my Telegram channel. You can message me. So I think already I have solved. I will upload the PDF on my app. Download the app from Google Play Store, guys. Or you can also join. This is my Telegram channel if you are new. Then Electronics by Sanjay Rathi. Here you can post your questions. And just we are taking what some sessions for 2026 and 2027. First of all, watch the session. अगर आपको लगता है कि frequency match हो रही, then you can join. Separate batch for English and separate batch for what? Hindi students. Okay. तो यहाँ पर है for electronics, electrical instrumentation, live and recorded classes are available. For more detail, you can call at that number. Live sessions, recordings, previous year questions from the textbook, doubt clearing sessions. आप देखो पेपर होने के बाद तो कोई भी बता देगा कि क्या बनाना है, लेकिन आप पेपर होने से पहले देखिए जो डिस्कशन होता है. अभी मैंने एक सेशन लिया था क्या कंप्लीट एनालॉग का रिवीजन. आप जाके देखिए फॉर्मूला कैसे हमने क्वेश्चंस बनाए हैं. करीब करीब वैसे ही क्वेश्चंस आते हैं जैसे मैंने बार बार बोला है. डिफरेंशियल एम्पलीफायर इज अ वेरी वेरी इंपॉर्टेंट टॉपिक. तो डायरेक्टली डिफरेंशियल एम्पलीफायर का इनपुट रेजिस्टेंस कैसे निकालना है, CMRR कैसे निकालना है, डिफरेंस गेन, कॉमन मोड गेन अभी भी इंपॉर्टेंट है. कल आराम से रिलैक्स रहिए इलेक्ट्रिकल वाले. गुड लक फॉर योर एग्जाम्स. अच्छे से नींद लो अभी पूरी और फ्रेश माइंड के साथ कल एग्जाम देने जाइएगा. और देन इलेक्ट्रॉनिक्स वाले जो स्टूडेंट्स हैं वो कल शाम को मिलते हैं, फिर से एनालिसिस करेंगे कि इलेक्ट्रिकल में जो बहुत सारे कॉमन सब्जेक्ट्स हैं उन कॉमन सब्जेक्ट से कैसे क्वेश्चन आए हैं. एंड स्टार्ट योर प्रिपरेशन नाउ गाइस. तो ये है. अगर किसी भी डिटेल के लिए आप मुझे मैसेज कर सकते हैं, कॉल कर सकते हैं. PDF के लिए आप एक बार ऐप डाउनलोड कर लो और इसकी PDF देख लीजिएगा. ओके. तो इलेक्ट्रॉनिक्स वाले आपके पास टाइम है तो थोड़ा सा आप देख लो कि क्वेश्चन को कैसे बनाना है. ओके देन, थैंक यू एंड